Okay, so you watched that 30-minute long video, 31 minutes long video, and I was basically talking about the directional derivatives. I did the derivation with you guys, and hopefully you understood what was happening. So now let's look at the additional exam for 2023. So now let's look at question 5, and let's see if we can be able to solve this problem really. So now they say find the direction for which the directional derivative of f of x y is equals to that at a point minus 2, 3 is equals to 0. So what we know, okay, before I do that, let me just talk to you first. Let's just revise the stuff what we know. So from the last video, this was basically stated that the directional derivative is equals to this, and I also stated that this is equals to something like this: the magnitude of this one multiplied by the magnitude of the unit vector multiplied by cosine of the angle between them, and then this one is just 1, and this is just the directional the gradient vector of f multiplied by cosine of the angle between them. And I said this is fixed, if you still remember what I said. So the only way that that can be 0 is this: if the angle is equals to if this angle is equals to 90 degrees, meaning that those two vectors, they must be perpendicular to each other, and that's where you'll get that to be 0. Okay, so the solution to that. Let's look here. We have f at x, y. So first let's find the gradient vector of f. So let's find partial of f. If you find partial of f with respect to x, you just get 6x minus 4y, and evaluate that partial with derivative at that point minus 2, 3. So you evaluate minus 2, 3, and then that's technically gonna give us 6 into minus 2 minus 4 into 3. That's just gonna give us minus 12 minus 12, and that's technically gonna give us minus 24. Okay, so and then we can further proceed and find the partial of f with respect to y, and the derivative is just going to be, this one is going to be 0, and this one is just going to be minus 4y, and this one is just going to be okay, yikes, okay, minus 4x, and then this one is just going to be 4y plus 4y, and that's the partial of f with respect to y, and therefore we can evaluate that partial derivative at a point minus 2, 3. So minus 2, 3, that's just going to give us minus 4 into minus 2 plus 4 into 3, and that's just going to give us, this one is going to give us 8, and this one is going to give us 12, and then this one is just going to sum up to 20. And therefore, since we have this partial derivatives evaluated at that point, that means that we can get the gradient vector of f at minus 2, 3, and that's just technically going to give us minus 24 as that component and 24 the second component of that vector. So notice that we let our unit vector, notice that I said this, that you technically dot that with the unit vector. That's your directional derivative. So by definition, we know that how you find the directional derivative is we dot the two vectors. Okay, if we let our unit vector be defined by the components a, b, what do we know? So this means that the magnitude, we know that the magnitude of u is technically equals to 1. The magnitude of our unit vector is technically equals to 1, and therefore the square of that, a square plus b square, is technically equals to 1. Implying that, and then this implies that, okay. And then from here, this technically leads to saying that a square plus b square equals 1. And then if we use this information here, du of f at minus 2, 3, the directional derivative of that is equals to 0, implying that the dot product of the gradient vector of f dotted that with our unit vector is equals to 0, implying that this technically implies that we have minus 24, 20 dotted that with AB is equals to 0. So we have minus 24a. I'm sure you can do the dot product. So then minus 24, you just technically multiply the components. You can check my last videos on vector for 1644. And then that's where you'll get the idea of what's happening. Then 20b, then this equals to 0. And then if you solve for a, you technically get that a equals 5 over 6b. If you solve for a on this case, and then therefore, but here we know that a square plus b square equals 1, but here we know that a equals 5 over 6b, so this technically implies that we'll have 25 over 36b square plus b square is technically giving us 1, and therefore this technically implies that we can have like 36b square over 36b, over 36b square over 36, then 36 plus 25, that technically gives us 61. Multiply both sides by 36, then you get this, and then you get b square equals 36 over 61. So then you get that b equals plus minus, you get two values for b, plus minus 6 over root 61. Therefore you get two values of a, plus minus, plug b there, root 6 over 6 over root 61 there, plus minus that, you get also two possible values of a, which is just going to be 5 over root 61. So in what direction is this directional derivative equals to 0? It's 0 in the direction of two possible vectors. The possible vectors is that we have, the possible solutions is that you have minus 5 over root 61 is to minus 6 over root 61. Then that you get your directional derivative at 0. And also in the case where you get like 5 over root 61 and 6 over root 61, so you have two directions in which that vector is going to be. But notice that here you can technically take out the negative outside, so it's a scalar. It's a scalar multiple of that, and then it's just basically the same thing. So that's the direction for which that directional derivative will be equals to 0. Thanks for watching. Don't forget to share and subscribe.